100 years after Tillman invents the sandblaster, optical technicians construct a blaster which fires individual atoms. Without it, Keck's mirrors wouldn't produce sharply focused images. Now the technology is also used to dissect individual cancer cells. Sharpshooter Dr. Andy Bushby shows how it works.
So this is it, isn't it? Whoa, that's your atomic blaster. What do you actually call this thing for real?
This is a dual beam environmental scanning electron microscope.
Wow. Dual beam, you see, I'm loving that. But microscope, that's just for looking at things. I want to sandblast things at an atomic level.
Well, we can do that. Because this is a dual beam microscope, we have an electron beam that comes down here that we use to look at the sample. And over here we've got an ion beam which we use to cut away the sample with great precision.
Ions are electrically charged atoms. They can cut stuff atom by atom. Andy wants to show me how.
Exactly.
In the interests of science, one of my hairs volunteers as a guinea pig.
Ow! That's my hair.
That's one of your hairs. Yes, that's where you've glued it down with some glue. Yeah, and there's your little hair sitting across there.
So how close can we go with this thing?
Oh, we can get in there and look a little more closely. And we can see the size of your hair. And we can come down and look at one of these flakes.
So that filling the screen now is one of the hairs off my head.
Why don't we write your name on it?
That'd be ridiculous.
Yeah, we can do that before your very eyes.
On a hair.
On a hair. Here we go. Now, the ion beam is delivering about 23 million atoms per second into a spot that's about 50 atoms across.
And you can see it starting to rise.
This picture has been magnified 5,000 times. The eye in Richard is about 1,000 atoms wide.
So it really is working the same way as sandblasting now. It's just dozens and, well, millions of these things.
That's right, but on a very small scale.
It's a lot smaller, yeah, it's a lot fiddlier, I'll grant. Because that's my name. I mean, barely noticeable across the width of one hair.
One of your hairs.
And how do you use that then for polishing?
Well, here we're coming down vertically onto the surface so that we blast away a pattern on the surface. If we wanted to polish something very smooth, then we'd fire those ions in at a very low angle to the surface so that they just knock away eye spots on the surface and leave something that's very, very smooth.
So this process that can etch my name lost in the width of a hair, you're saying is heavy duty. And if you want to have some real finesse and polish, you send it in at a more acute angle rather than perpendicular. This is your heavy engineering going.
It's heavy engineering, but a very, very small scale, atom by atom.